Hello. Time for something different. Hi. Uh, you know what? I'm gonna add some documentation to the thing that Five Man just complained about, because now this is 2 out of 2 people giving up. Let's see. Okay. What you gonna do today? So I just published a squatting crate to crates.io. I'm planning to squat. I'm planning to make my own library that does something cool. I have the description written. It's called this. No readme. Oh, it's here, I guess. Oh, I see. So it's only on the GitHub. Callback provides a derive macro, which generates a vec-like data structure, except with a transposed row column layout. This means that you can take a slice across an entire column of a single struct field. So it's like if you insert multiple test objects into here, then all of these are back to back in memory. So you can take a slice across all of them. Whereas with a normal vec, you have this entire thing, and then you have another one and another one. So field 1 is not next to field 1 from the second value. It's field 1, then field 2, then field 3, then 4. It's layout like that normally with a vec. So it's just the rows and columns are transposed of like the fields. I haven't seen something that does this good, so I'm gonna make it. That's a little bit unfortunate that there's no readme, but at the same time, it's fine because it's just the squatting version, so that no one takes it while I'm doing this stream of making the initial version. But before that, I want to document how to use the API. How to begin development. Uh, Um, hmm, hmm, hmm. Uh, uh, mm, whatever. Okay. Is it called that? What is it called? Maps validation. We can just do it like that, right? Just one step. Run. Um. Oh. Oh, actually, the Docker registry is private, isn't it? Hmm. Um. I guess we could organize that. Um. Is there a more minimal? You could. No. I don't. I don't really know how to make it good. Um. Microservice architecture. Uh, oh, I've just had it open forever, I see. Meh. Okay. Well, that didn't work out like I wanted. Okay, onto this. Can't see your other screen. Oh, I've been doing stuff the whole time. Well, thanks for telling me. Damn. Squat. I think I got a squat. Oh, squat. Oh, squat. Quad doing squat. I'm squatting, crate squatting. Because I haven't written it yet. Oh, so eh. Eh. So the old vec. I should probably organize it like exactly like this. So this guy's called mod. Alec. Okay. Okay, so the problem is that there's not really any benefit to the inner and inner type stuff. Raw vec and then raw vec inner, yeah. Yeah. Except there is benefit. That's a lot of coding. Yeah, this is like a roadmap of the work that I have to do to implement this object. Oh my god. Okay, let's make a module called callback. test. Play your game because I'm really good. You have no obligation to the stream. You can do whatever you want. Feel free. So raw. Why don't I call it like raw or something? Because like mod new file raw. Struct of Arrays? Data-oriented programming? Yes! Yes! Correct! Ding, 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 ding. Okay, so I guess I'll move this crap to some sucker like this. We'll see how that goes. Rar. Mod rar. Just figure out what the hell going on. Phantom data. I'm gonna have to use freaking like no STD type business and stuff. Oops. Okay, what is that? Okay, I have to do the malloc. I'm gonna have to allocate. I haven't done allocating before. So this dude right there is private, which like, ooh, okay. Rar. Do I need? I don't know. Did you make maps in Surf? No. No, 0. Pretty sure I have 0 maps. Alright, I'm just going to use a regular old usize for the old capacity here. So then this type is raw. Test. Is it called test? What the hell is my thing called? Test. Alright, buddy. Okay, so pub crate, sure. So we're gonna have not this, it's gonna be inner is a test raw vec. It's a callback. It's a raw callback. I'm not doing it right. That boy ain't right. Callback. Oh, bubby. Okay. This one here. I think we got T and A, right? Oh crap. Wait, is it just like that? I forget. What am I doing? What is this? Vec mod. Okay, vec is right here, right? It's just like right at the top. Len. Oh. Okay, that's kind of weird. So use crate raw. Boom gaming. Okay. So this is the reference code. T A. So do we care about the T here? T is like built into the code. Okay, so this thing is just like O T and that's it. I can just keep this type business. It's not, there's no extra cost. Okay, you go away. T. Do we want T on this? I don't think so. Yeah, I'm pretty sure we don't want T here. And then, so it makes this inner guy like a little bit whack, but like, cause it's just pretending. But we can say like, oh wait, yeah. Must use inline, surely. Const. Love me some const. Okay, then test raw. Yes, sir. Okay. And not real. Oh, it's called buff. Sure, whatever. Okay, and then none of these methods exist. Type situation. So this is going to be a lot of slow going implementation. I guess I'll try to get new, push, and slice field out the door. Field 1 slice. Self. That's it. And it gives a freaking slice of U8 type situation. Oh. Okay, so we need the old actually implemented type situation. RAR. Wait, global. Oh. Where's the implementation for oh, I see. Okay, it's a little tiny guy. It's like, oh yeah, we do it like this. I like that. That's sick. I actually didn't realize that. What is track collar? New GG. This dude. There's no T. We ain't doing that. T layout. Is that's got to be like private compiler type situation, huh? And no layout found. Ah, jeez. Oh, there's no T. Inner. We don't need like crazy stuff. With capacity zeroed. Interesting. What is this? Inner global with capacity. And then new. What is new in? Who wrote this? New in. Goodness gracious. We got about 4,000 lines of code to go over here. I kind of want to just like skip it and make an implementation using just the bare minimum. So we got new, push, slice. Min non-zero cap. Tiny vecs are dumb. Oh, let's go. 8 if the element size is 1 because any heap allocators is likely drawn up to request slices. 4 if elements are moderate sized. Less than 1 kilobyte. 1 otherwise to avoid wasting too much space for very short vecs. I was thinking about this. So there's a problem. I haven't even written this. I've already thought of a problem. So in the old documentation here, I wrote I put the star there. Callback can be smaller than vec when the struct has padding, since no padding is needed in the transpose layout star. So imagine each field wrapped in vec. So it's like, oh wow, it's a vec. It's a vec. Why is it opening over there? So it's like you went here. This is essentially, it's not essentially what the macro does, but like, imagine this, right? You take the fields, you go vec. Oh my god, now we have a struct of arrays. Oh wow, it's a struct of arrays. And as you know, each of these has their own like layout properties. And they don't affect each other's padding. Whereas if you have this overall struct, it's going to have something, it's going to have like a size. Wait. Oh, ooh, unlucky. Look at align 04. Unlucky. So does it rearrange any fields? Let's see. Offset. Yes, it does. Offset 4, offset 6, offset 0. So it has rearranged the fields. I'm looking at it right here. So this creates the overall alignment of the struct. So starting at memory location 0 is this field. We can actually write it down. So what does the memory layout look like? So I'm going to type this character and how many bytes it is. So field 4 is 4 bytes right there. It says that the offset is 0. So at the very beginning, it's the field 4 bytes. Size is 4. Then next, offset 4 is this thing. Size is 2. Line is 1 byte. So size 2, field 2, 2 bytes. And then now we're at 6. So offset 6, size 2, field 3. So field 3 is right here, takes up 2 bytes. And then size 1, align 1, offset 8. This field 1 goes here. And then the overall size is 12. So there's 3 bytes of padding. We can put those together. So this is what the memory layout of this test struct looks like. It's kind of like weaving through, right? It's kind of like, why would I do that? But that's to like optimize being able to use compiler tricks and like data oriented design stuff as best as possible, and like making sure it all packs together as best as possible. Because like if I add a new field here, then it'll just smash it on the back, I think. Yeah, no, No, I think it just changed the entire layout. 4, 8, 6, 7. Yeah, it changed the entire layout. So it's doing things. Yeah, so if you have a vec, like a vec test, like that, then what it's going to do in memory is it'll just go like, here's our first one, here's our second one, here's our third one, here's our fourth one. Just the entire struct back to back to back to back. But then what our test call vec does differently is it goes, it depends on the length of the allocation. So let's say we have room for 4 structs in our thing. So it's going to go like, how do I represent it? It's like, it's kind of like this. 2, 3, 4. And that is full. And then it's going to go like this. 1, 2, 3, 4. And then like this. 1, 2, 3, 4. And then like this. And now the difference here is we don't need the padding. So there's 16 bytes, that's field 4. There's 8 bytes, that's field 2. There's 8 bytes, field 3, and 4 bytes, that's field 4. And the vec is full. So this is, the entire memory is filled because it only had capacity for 4 items. But because it knows the offset and the layout of the struct, it can have just the right amount of room for 4 items and put them in just the right place to be a big gamer and do amazing gaming. Very good, very nice. Len 4 cap 4. We need to say capacity as well. Oh my. Oh my. Yeah, so this is what I'm making. This is what it means. It's like the memory layout is transposed. So you go here, you skip to here, to here, to here. Then you go here, to here, to here, to here. Then you go here, to here, to here, to here. Then you go here, to here, to here, to here. And you don't need padding, which is like a minor gain. Usually padding isn't that big of a percentage. It's worth the trade-off of like using more memory versus having proper alignment, memory alignment, for reasons I don't know off the top of my head, but I'm pretty certain. I'm learning. This is why I'm making this. It's because I haven't actually called an allocator before in Rust. So if I'm making this thing, I'm like making vec basically. So I'm gonna have to like use the standard library as reference and write my own code that calls the allocator and like allocate. Allocation is something you have to do. I don't know what I'm going. Okay, so this is what I want to implement. Rust programming rewrites Rust. This is based off of Zig multi-array list. I watched a YouTube video of the Zig creator going like, dude, Zig is so good. Oh my god, it's so good. And not exactly, but like they were talking about this thing, and I was like, oh my god, that's so good. Wow, that's so good. And I remembered it when working on my friend's project a couple days ago, and I remembered this thing, and I was like, this is exactly what's going on, but we don't have this in Rust. We actually don't have it. And I looked for it on crates. It's not there. So where is it? We need it. Struct of Arrays, also called a multi-array list. Instead of storing big structs in arrays, storing each field as a separate array. If you need to fetch the full struct, you reconstruct it from the arrays. Do they really do it as separate allocations? I actually don't know. I should probably research. No way. Is it? Wait, is this like the actual source code? How big is this? Pretty small. So I'm guessing it, yeah, comp time. There's a lot of comp time type stuff going on. Okay, so they return struct. Oh, interesting. Huh? Multi-array list does not support tagged unions. I don't believe that. Wait. Oh, untagged unions. Are they storing separate array lengths for tagged unions? Huh? Am I just high? Cached? Why is it cached? Is it cached or compile time? Not normally stored. Ziggy. Pointers. Oh no. Undefined. Oh no. Oh no. Okay, so literally, it's a struct of arrays. I thought they were just transposing the memory layout. Mine is going to be better, but also worse. Different trade-offs. I don't read Zig, so this doesn't mean much to me. To multi-array list. I realized that the transposed the callback thing can be the same size as a vec and use a single allocation. And you don't need these multiple pointers where this is like an array of pointers. You can just use the compile time field offsets to define how the fields are accessed and written, and just like multiply by the capacity. Oh, okay. I think align. Yeah. Align. I think the minimum size should be the alignment. Small vecs are stupid. Why don't I write that now? Huh? Where's the thing in the Rust library? It's like, small vecs are stupid. It's stupid. You're stupid. Anyone who does this is stupid. Stupid. Dumb? Yes, tiny vecs are dumb. Okay. Min non-zero cap. Const. So this is actually going to depend on our alignment. Can you min? Do we have min on? Yeah, we're gonna need probably use this function and be like, yes, this is the recommended, and then also, or I guess it's max, and then max against the alignment of the struct itself, so that you don't accidentally have unaligned memory slices, and it's like, the alignment's off, it doesn't work. I think that makes perfect sense. Oh my god. Okay, so let's slap this together. Where is this? Who did this? Ravec. Rar. So we're gonna do. Wait. Oh, it's over here. New in. Did I write that? No. How close is this? Okay, so we have ravec, enter with capacity, ravec. So we want like this. Huh? So it's like not enter? Okay. T. So we got T, but T is implicit based on our code generation. So oh dear. I yeah, unlucky. I'm just making a prototype, so oh, I guess I don't need that. Use create callback T. Let's go, and then T is here, test, and then close it, and then okay, so we got this function, but then we also need a lot. Wait. The size is always bigger than the align. What happens here? So size 1, 8. Okay, so we do need max. As ord. Oh, hell no. That's not const. Oof. Am I allowed to use like a const block? Oh dear. Okay. And then we have equals to, what the hell? Huh? That was weird. Okay. And then if is that allowed? Okay. We'll say const just for lulz. The transposed layout must have correct alignment for every field, I guess. No S. So if this is less than that, then we want the bigger one. We're doing max. Let's just write max. Alrighty, righty. So that's actually handled. I didn't know about this. But I was thinking about it. I was like, oh, it's dumb, isn't it? Well, that's pretty cool. Quit it with the spaces, man. Oh my god, bruh. Spaces. Oh, they must have added that because like they didn't have it before. Thank you, Zed editor. Okay, so we don't need phantom data, but probably it would be good to have phantom type. Trait. Right, I was thinking like, oh, trait. What if you have a trait? But then it doesn't work. Because of this? Because like you need these custom. I guess you could have it be a partial trait. You have like a custom push implementation. But like if you can do the whole thing as a trait, I don't know if that makes sense to do. Excuse me, at all. I'm gonna heat this up a little bit. Okay, what I want to do is the red underlines. Make the red underlines go away. See what happens. just a tiny amount of coffee left. I can just finish it up. Oh my god. Capacity grow 1 as mutt. 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 Huh? Oh, Vec. Ha ha ha. T. Oh. Okay, so this is saying this guy not the same. T. This is T. But I'm saying ah. Ah. I understand. So this is not the same thing. So I can go like ah. Ah. And then this is like okay. Red underline. Red underline. So this is not real. Let's trace that. Who did this? New in inner freaking dinner. Allocator. Alligator. Okay, so this goes with this. I do believe. This is like, oh, I'm the new thing. And it was right here. God. So we don't need this. Huh? STD mem side. Wait, it's a trait. Oh, Schnapple. Oh, Schnapple. Oh my god. Really? It's beautiful. It's unstable. Okay. We could just do this and be like whatever. Surely, right? Ooh. Ooh. Layout is private. I forgot how you do layout. What does the allocator do? He-Man. So it's like doesn't tell me anything. Okay, what about here? Layout. Who did this? Core alloc layout. Pub. Core alloc layout. All right. Self. That is not correct. That is not correct. This is test. Already ready. So now we need to track this guy. Actually, hey, wait a second. New in capacity in. Is it real? Is it trying to do that? No. We. We'll probably need it. What is track color? Let me look at that. Oh. We don't know. Okay. So what is this on? Raw vex. That's at this level. Test raw call vec. Okay. Who are you? So this is. Okay, we'll probably need this open. I'm just gonna put it over here. Phantom data. A allocator raw vex. So that's like a allocator. So that's down here. New in. So that's like, oh, right here. Yes, sir. With capacity in A. Alignment. Wait, what? Yeah. Yeah, you could so easily write this wrong, and it would just like blow up. A. Alright, there's no phantom data. Okay. Who did this? No function. Unreal. So, do we need a global? So we're tracing to here. Oh, look at that. Oof. Try allocate in. So do, and then do. Inner, boom, and then do you need to do a trait? What the hell is that? Try allocate in. Okay, that's like something else. Oh goodness. Wait, what? Try with capacity, try allocate. Okay, there it is. Okay, so there's stuff going on here. Hello. I need like this function bloats the IR. Right. In it. Alec in it. Okay, so what about the just new? How about I'll just put this off. So I'll do tabs. We'll just do new first. And with capacity type business later. New. This guy. And it doesn't exist. Okay. New. Where'd it go? A. Okay. Paste. So this type is actually this type. A. All right, and we're not doing this type because it's private. So we're just gonna do this and see how that goes. 0 caps. So I saw that before when I was poking around. Let's go there. So you're just going like, oh no, it's unsafe. Oh, but it's actually literally 0. Alignment. Can I just say like, oh yeah, it's alignment, and then we're good? No. Putter alignment, would that work? Unstable library feature. Right. Wait. We were... Where did it go? It's right here. Layout. Alignment. So I said alignment. Oh. Wondered what you're doing exactly. What's with that look? This is the I have no idea what I'm doing look. I'm actively learning, I think. Ooh. Ooh. I'm learning for years, of course. Do you think programming is easy? So I'm making a library that is cool. So the idea is you have a struct with fields, and then you derive this other struct, and it acts like a vec, but the data layout is transposed. So it has different trade-offs and properties, and you might want to use it in certain situations for certain reasons. But yeah, it's all like allocate and biallocate and stuff. So learning about allocators. Examples. So if you're going for maximum performance and you have an array of structs and you're iterating over it, but you only access one of the fields, one of the struct fields, you're like jumping over a bunch of information to access that one field from each struct. But the actual CPU hardware is like loading in the full data even though you're only accessing one field. So if the layout is transposed and the data for each field is now next to each other, then you don't have to evict as much information from the cache. So it's faster in that case. Or if at the end of your computation you need that slice of information, it has to be in that layout anyways, then yeah. So this is like a visual representation. So this is a test struct. It's 12 bytes long. So there's 12 bytes here. And I looked at the field offsets and alignments and stuff. And so field 3 is right here in the layout. So this is the first byte. So the first 4 bytes are occupied by field 4. The next 2 are field 2. The next 2 are field 3. And then there's field 1. And then there's padding. So this is the in-memory layout of this test struct. So if we have a vec of test structs, an array, of length 4 and capacity 4, then this is the memory layout of that. It's just like back to back to back to back. Cool. And so that's 12 times 4 bytes. But then if we have this cool transpose structure, then this would be the memory layout. You would have this field first, but you notice that they're all back to back in memory. So that's field 4, and you could take a slice across only field 4, but all of the values. So if you're iterating over it, you go and only read field 4, and it like is populating the CPU cache with the values, and you use every single one of them. And so it has to evict the cache less often because you're using all of the data that you're reading. And then like the other fields are there as well. So you can see it's in the same order as this: 4, 2, 3, 1, 4, 2, 3, 1, but it's transposed. And you also don't need this padding information, because like that would just be like here, just be a bunch of padding at the end. So you actually save these 12 bytes in the layout. This is called a struct of arrays. And I looked for a crate that does this, and I couldn't find one. So why don't I make one? I'm sure it'll be garbage, but like I'll learn, and maybe I'll be able to make it better over time. So I'm basically copying the standard library, vec. What are we doing? Go on YouTube and scroll back by 5 minutes. I explained everything. Oh, Leo, is that Roblox Leo? I'm doing programming. Yeah. I'm explaining the technical details. I'm amazed that I'm able to understand this. Hell yeah. Allocation, struct layout, in memory. So this is not actually for Strafe Client or Roblox bhop or anything. I might end up using my little library here. I'm basically doing this just to learn about using allocators and to make a cool library for a project my friend is doing. I think C is better. It is certainly older and more mature. I think that's a strange statement to make. Better. There's always a metric that you're measuring, and depending on what you're measuring, there will be a different order of which tool is best for the job. So if you're trying to contribute to the Linux kernel, C is better. If you're trying to contribute to a Rust project, you might have trouble contributing C code. I just wanted to say that. Pretty much if you want to write Rust, you should learn Rust. But there's like technically what is it called, Turing machine, technically they're all Turing complete, and technically they can all do what each other does. The main benefit of Rust is the correctness that it enables, where you can write rules that the compiler enforces onto you. So you can say, this is how my data works. And then if you try to break your own rules by accident, the compiler will go, look, you broke your own rules. So it prevents you from writing stupid bugs that would you would otherwise not have caught. What? Rust is pretty cool. It's very good for writing correct code. You get to teach the compiler how to enforce correctness. Okay, I need to implement these functions. Am I done with this one? There's no red underline. Okay, so we got this red underline here. Fix the red underlines. That's the Rust experience. Because everything is so correct, if you make all the red underlines go away, there's like a really good chance that it just works. Okay, how do we do like this? I was gonna go try this. Can we do alignment? Is that real? No. As non-zero. So this is a private thingy. Align. So this gives a use size. Non-zero without privateness. So are we... So we have a pointer to like some low memory. Based on the alignment. Who did this? Align of. So this is that's the same function. Alright. Use size. Can we do better? Is there like a line of like this? Oh, and then does that give you something cool? No. Okay, so is align always non-zero? Educate your compiler so you don't make mistakes. There's pointers in Rust. If you drop down into unsafe, then yes. There are some pointer operations that are safe though. But like dereferencing a pointer that may or may not be null, you never do that. You always work with references, which are guaranteed to be non-null by the compiler. So I never really touched unsafe Rust for months and months. It's it's very ergonomic to work within the Rust framework of references, the borrow checker, and the concepts that it brings forth. It's only when you're like implementing a low-level library like this. So Vec is like the C++ vector that uses an allocator. So it's doing like the inner workings and stuff. So I'm trying to re-implement my own thing that's the same but different. You did before. Did what? Did use pointers? Did make mistakes? I have worked with pointers before in another little library experiment thing that I did. Touch. Unsafe. Unsafe. It's unsafe. Unsafe just means allow operations that might lead to undefined behavior. It's a really amazing tool to cordon off the code that can actually potentially have memory safety issues, so that if you do have a memory safety issue, you know exactly where to look. Because in safe Rust, you can't have memory safety issues. So you don't need to look for memory safety issues there. So it's basically just a marking tool, so that if you find yourself with memory safety issue, you know where to find the issue. You don't have to look through your whole code base. Mainly use C++ for everything. Wonder if it would be hard to learn Rust and where. So Rust has a lot of syntax. There's definitely a like wall that you have to climb over to get in. How I learned is with rustlings. S. It's a series of exercises where your job is to fix a compiler error for each example exercise. And it like gets you used to reading and writing Rust. This is really what like bootstrapped Rust into my brain. And I was like, oh, I know, I want to start a project now. I have an idea. Whereas before it's like, how do you write anything? Yeah, so very good. Some people say read the Rust book, but like that's not how I learn, so. Okay, so this is a freaking zero business const function. So the problem here is that the standard library has private types, and it's like using them everywhere. Alignment enum. Oh goodness. I'm not sure where to go with this, because I can do non-null usize here, and then that's done like that. Uh-oh. Oh, no. What is this? Non-zero. Oh. 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 So these are like types with particular enforcements. Gah. So it's like, oh, this will never be 0, and it enables optimizations like you can not use extra space when you have a pointer with optional values. How do I explain this? Optional values. So Rust doesn't have null. There's not something to represent null. Like you can have a raw null pointer, but you generally don't use that from safe Rust. So instead it has this optional type that has an inner type. So the option is an enum. It's either none or it's some t. This is t in here. We can go to the definition. There's a bunch of like compiler marking stuff, but like t, there it is. It's t. T, some t. And what the compiler can do is if you have this non-zero type here, but then if you have option non-zero, then this is no bigger than usize. It's a zero cost abstraction. So in memory, it will be the same size as usize, but now you have special semantics surrounding the particulars, and you'll never make the mistake of accidentally using 0 when it was invalid, because the option type forces you to have 2 branches depending on if it's none or some. So you can never forget. You've taught the compiler how to enforce your own rules. I'm going to do this and call it a day. Use num non-zero. So now I have to make a non-zero. New. And then that's going to be option, I think. Yeah, so we'll just do unwrap. Is that allowed? Oh, it has to go in here. Okay. Oh my goodness. I've never learned anything by reading. Can I say a rule example? It's kind of what I was just explaining. Option. This is a big one. Let's see. This would be a good review. So I go to my sandbox. Okay, so I have this saved. Fool, you fool. What's going on here? No, okay. Okay, so let's do an optional reference, which would be equivalent to a raw pointer. So let's say we have this value a, which is 5. And then we have this other value, which is an optional pointer to a. Maybe it exists, maybe it doesn't. I think it'd be better to make some other function. So let's say oops. So this this takes an optional reference to let's call it I32. You know what? I like unsigned integers better. And what does it do? I don't know. Nothing. I don't really have something concrete here off the top of my head, but I'll just stick with this. So this function signature says that maybe I have some reference to an integer, or maybe I don't have any reference to any integer. So when I call this function, I have to say, yes, I have some reference to an integer. Or I have to say, oh, I have no reference to any integer. And does this say what size is? Yes. So let's talk about the size. All right, let's say struct align. No, A. Amazing. It's just like a helper to let us see what's going on. So option usize. Okay, do you know what usize means? Usize is an integer that's the same size as a pointer on the native architecture. So it's 32 bits on a 32-bit architecture. It's 64 bits on a 64-bit architecture. Amazing. So when I say option usize, that is 16 because you have to represent the entire range of integers, and then also the like Boolean, that the tag for the tagged union enum of none or some. There's a bool that says it's none or some under the hood or something, but then you also have the entire range of usizes. But for a reference is guaranteed to be non-null. It will never be 0. So what you can do is you can pack that in, and instead of it being size 16, we have a reference to let's say U32, and we have to do this. But now the size is 8 because it's an optional reference, and Rust knows that references are never null, so it can represent the none variant with 0 in memory. But you never see that from code. It only exposes the rule of you always must handle when it's none. So if I go back, so you see this is size 8. If I go back, this is size 16. So it's able to pack it better using the zero cost abstractions, guaranteeing the rules. But this isn't very concrete about like how it actually works and what actually happens. Oh, some none. Ooh, I have to match it. So now inside this function here, if I want to get at this value, I would have to do something like actual value equals a dot unwrap, and then dereference. And then now I have a U32. Well, that's annoying. Why not just work with the pointer directly? Because this is going to panic. But like, there's ergonomic ways of doing it. You can do like if let sum actual value equals a. And now I have this here. And I can also do deref, deconstruct. And now I also have this print actual value. Wow. But now you see it's like it's written as an if statement. So I explicitly in the code have said, if it's a none value, ignore it. Instead of having this code path that will panic, I have handled the optional value. Syntax is killing me. Yeah, Rust syntax, there's a lot of syntax to learn, and it's weird, but in the end, it makes sense. So then another way to do this would be if you want to actually handle both variants, then you match the value. This is probably the most powerful statement in Rust, is match. So if a is some actual value, then print the value. I'm going to deref U32. If it's none, then we print no value. Yeah, so Rust is all about correctness, explicitness, lifting possible code paths and like errors to the explicit syntax level, where as you read the syntax, you can see all possible failure modes. So like the exclamation point is denoting a macro. So every time there's a macro going on, bang, there's a macro going on. Every time I have some sort of option or result at the, and I have to match it or handle it or pass an error as a value up the call stack, a macro. Yes, there's it's a whole can of worms. There's so much syntax. But at the core, there's this concept of correctness and explicitness. Everything is a struct or an enum. It's a product type or a sum type. And you get these rules, and the entire language, Rust is written in Rust. So I can go, this is like a built-in language thing, right? I can go see what the code is for optional values. It's just an enum. I say air quotes, but it is literally just an enum. You could define your own optional value. So option is an enum. There's this other type called result. So result is how you pass errors as values up the call stack. But it's modeled with primitive types in the Rust language. So this is what a function signature for a function that might return an error looks like in Rust. It's this enum of, there was no error. Oh, or this was the error that happened. Instead of like a try catch and like throwing errors and like you're not really sure if the function can possibly return an error based on the function signature, in Rust, it's lifted the possible errors to appear in the function signature. So when I read any function signature, I know whether or not it throws an error. And then I'm also forced to handle said error and either like handle the error or bump the error up the call stack to the next level. And then my function now has this result type signature as well. And whoever's calling my function knows for sure that there's an error possible. So if I accept this option, I can say, we got the value. There was no error. Or I can say, oh no, there was an error. We'll call this like the no value error, let's say. No value. Oh no, there was an error. No value. Oh no, and this is now a valid Rust function. And you can also like this. Okay, yeah, it's just like it's high level and low level at the same time, where it's built off of these primitives, and you can create your own rules, do all of this high level stuff, but then it also still compiles away to just integers and stuff, right? To machine code. Your rules only exist at compile time. There's zero cost abstractions. So like this struct has only one possible value. So the size is 0. It's a zero cost abstraction. You can't shoot yourself in the foot is the idea. One of the many excellent Supreme Rust ideas. Returns the value or what? So that was just the LSP server omitting all of the junk surrounding this. So like you have this giant like explanation and like documentation and stuff. So I could like remove all of this junk and get it down to just the actual type signature. So I'm going to do that. My thing. So here's the actual type signature. So here, oh, is it going to let me do that? No. I'll say my option. It still says it? Oh my God. So it's omitting the inner information. This is the LSP doing it. Yeah, this is a comment. So yeah, so this is my option. I can actually do this, and then it still works, he said confidently. Why doesn't it work? Expected my option found option. Right. So this is using Rust's option, but I need to explicitly specify my option. Same here. Oh, I didn't do it. Okay, so I've just built the exact same thing as Rust option. What's your IDE? This is Z editor. Written in Rust. Yes! And open source. Try the rustlings. It'll like really familiarize you with the syntax and what's available. You'll find that Rust is an extremely well thought out language, right to the very bottom, building from the ground up with these primitives, and then the entire language is written in the language itself. And there always seems to be something dedicated for the specific use case, like Rust string types, meme, XD. So, oh no. Okay, can I see the image? There we go. Okay, so these are all string types in Rust. These are all different types. Why do you need all these string types? But every single one of them has a dedicated use case. I don't think Rust links by itself is enough to learn. It was for me. I continued learning by writing my own projects and stuff. Writing code is like how you learn, which is why Rust links is so good. Is because it makes you write code. It's changing code that's almost correct. Editing code is a very good way to learn a language, right? So this is a string slice. This is an owned string. There's a byte slice. There's a reference to an array of fixed length, array of bytes of fixed length. There's an owned extendable array of bytes. There's a reference to a single byte. You would never use that. There's this OS string. This is the slice variant, and this is the owned variant. So that's like when you're passing a file path to the operating system, this is the type it uses, and it like is generic across different operating systems. And then this one is like the same thing, but not passing it to the operating system. This is dealing with paths in Rust. There's a reference variant path, and then there's the own variant path buff. Then cster, this is for interfacing with C. This is the null terminated string. This is the reference slice variant, and this is the own variant. And there's a static reference to a string slice. It makes no sense when you don't know Rust. What the hell is the string slice? So this is slice syntax. So I can say A is a slice of U32s of some kind of length, and then now when I call my function, I can say yes, these are the U32s. And there's valid Rust syntax. So I'm passing a reference to this array. Values like this. Reference to values. So it's turning this fixed size array into a slice that knows its own length. This is a fat pointer here because this is a dynamically sized type. Rust syntax. Rust, it's rusty. Yeah, Rustlings. Go do it. Go do it. Find the time. Rust introduces a lot of new ideas. We haven't even touched on the borrow checker. The amazing thread safe properties of the borrow checker. All of the foundational ideas seamlessly worked out. There's async syntax. There's these mutable references. It makes dealing with multiple threads effortlessly safe. You will not get data races or any memory safety problems when you write safe Rust code. Spawn threads, pass values between them. Don't understand the quote. Oh, do you mean like lifetimes? Or talking about the like tick? Like this guy? Yeah, that is probably one of the biggest challenges to understand. It's codifying something that exists in all programming languages, but is never explicitly codified. It's so Rust models what your data is, right? It's sum types and product types, And there's this algebraic type system of I have this enum inside of a struct, but I can also do structs inside of enums. I can have an enum of a struct of an enum of a struct of an enum, and have these like compound types. But Rust also models when your data is with lifetimes. So lifetimes are essentially a scope. So like this would be a lifetime from here to here. And the Rust borrow checker checks to make sure you don't use after free. But it's all statically checked at compile time. It proves your code has no mistakes like that. No double free, use after free type situation. Resource acquisition is initialization, RAII. Basically, that is foundationally built into the language with zero cost. So instead of having these like shared pointer and unique pointer, you have just reference and mutable reference. And because it's all, there it is. Because it's all checked at compile time, you don't pay that runtime cost like you do with C++, but you get all the same benefits as using those safe abstract. I scare quotes safe, but it is literally memory safe. There's so many cans of worms in Rust. It's all like you can also have a mutable reference to a slice. I'm definitely gonna do that. Have underscore mutt. Don't say mutt. People will hate you. Mutable reference to a slice. I gotta get back to working on this library. Rust is so fun to gloat about. Like, it's the best programming language. You can't really beat it. C++, it doesn't got it. They don't got what we got. It's so interesting how well thought out it is. There's so many amazing things you can do with it. Okay, the red underlines. Make the red underlines go away. Okay, so I have no more red underlines here, which means that I'm done. But now I have to do dot capacity. So let's go find that in vec. Capacity. Help. Oh my god, there's 200. All right, I'm gonna cheat and use the LSP. Vec capacity. Help capacity. Go to definition. Oh, okay, that's the definition. Okay, go one further. Capacity, huh? Huh? Okay. Well, let's start pasting. So is this implemented here? Ah. What's the outer? There's so much code. This is the standard library. You see it's well documented. Okay, so it is in that thingy. So it's like this. Push capacity. Alrighty, ready. Alrighty. Where did I put my cheat? Here it is. Go. Inline, sure thing. I'll copy that. I know what I'm doing for sure. Yes, definitely. Okay, so then we have another layer here. LM size. I see. Okay, so that is on this guy. We'll do tabs. Cap as inner. So my cap doesn't have that. usize max. Really? Oh, that's weird. But it makes sense. So what it's saying is, if you have a vector of items and the size of the struct is 0, well, you can contain infinite, but as you push items in, they don't exist, but the computer limit is usize. It's an unsigned integer with the size of pointers. Rust uses usize for like list lengths and like list indices. So if you try to get how many possible, that makes sense. Cool. Oh my god. Okay. Okay, did I do it? Okay, size of t. So we know t is test. It's not generic here. Okay, did I make the red underline go away? Yay! Okay, on to the next. Grow 1. Uh-huh. Grow... Oh, that's a private function, isn't it? Yeah. Okay. Grow 1. Uh-huh. Huh? Okay. We're just gonna copy straight up. Where's this sucker? Okay, so these guys are like right next to each other. Push capacity grow 1. Push with no. Oof, excuse me. All right, let's just go back. Grow 1. Oh, I have to. There it is. So, okay, it's only on the inner type. RAR. Capacity, sure, whatever, I'll just paste it. I don't even know what that means. Have you seen the write macro? I can't figure out how to read it. Why are you trying to read the write macro? It's called write. You can't read it. I have actually. Recently, I was wasting time on something meaningless, and it involved the write macro. Let's see if I can find that code. Did I throw it away completely? I threw it away. Check? Is it check? No, it's upload. Submissions. Oh. Inner. Oh, no, it's this one. There it is. So I was writing this goober. So the arguments are something that implements the format trait, the format string, and then the format arguments. So like this value is inserted into... Oh, there's two values. This value is inserted into the first one because it's the first argument. This value is inserted into this, I guess I'll call it a capture, because the second argument. Woo! Syntax. Where's my code? Did I throw it away? I think I did. I shouldn't have thrown it away. Oh, I think I might have reverted it actually. Yeah, here it is. No. Where are we at? Remove. Yeah, there it is. So spend way too much time saving 1 nanosecond. Let's go. What exactly are you asking? Have you seen the write macro? How to read it? Are you just saying like, how do you use it? I have a macro defining a macro. No, this is just a macro writing a macro. Not because it's called write, but it's cogenning a macro. Call. Oh, so silly. The source code of it. Oh, you want to like look at this? Macros are very hard to read. Haven't tried Rust myself. How are your compile times? Does my code even compile right now? No. Is it that thing? Validator. All right, well, let's see. This is the map service validator. So this is an incremental build, not building from scratch. 9 seconds. How many lines of code do we got? Okay, that's mostly Golang. 6.7 Rust. And this is mostly generated code. Yeah, compile times, as my project grows, I haven't really seen it over 1 minute for like the most optimized build when I like set all the settings up really high. But like when you're first starting out, so like this one, cargo build release. Here's does this have, oh, it's gone. I don't know if it has dependencies left over, but let's see. Yeah, so it's compiling a bunch of dependencies. So this would be a clean build. It doesn't actually use any of the dependencies. Yeah, so 14 seconds clean build on whatever that was. Oh, there's this other file. Oh, I see. Okay, continuing. Oh, so that doesn't make sense. Layout. I'm doing... I swear there's another layout around here somewhere. Oh, there it is. Layout. Okay. The grow one. Next. Grow one. So this is here. Here. I'm actually gonna have to figure this out, I think. Oh, jeez. Yeah, no, this is gonna be a lot of work. So this is on the inner. Cap as inner. LM layout. 1. Handle error. Oops. Meme. So now I need this function. Oh my god. Yeah, so I'll need to look into the details of this. Should be just like right there, like this. Try reserve error capacity overflow. Okay, so they have this whole error situation. Explicit error values are very popular in Rust, where you enumerate all possible ways it can fail. It's very interesting. Like, I always treated errors like they shouldn't happen in other languages, and like when you see an error, it's bad. But like errors are just like any other flow of execution of the program. It's an expected. I got a hair or something. It's an expected outcome of the program. Like if you're like trying to write a file and the disk runs out of space, that's an expected outcome. You can represent that as a specific return value, represented with a particular error, and then handle when that happens in a explicit code path. Instead of like, oh no, an error was thrown. Who's gonna catch it? Nobody knows. Gosh. Ah, gosh. Wait, oh, is this const? No. Okay. Goobert. Handle error. Let's locate that function. Who did this? Handle error. Right. Central function because of the code gen cold. Okay. Here. Surely. Inner. Handle error is above. Oh, it's at the bottom. Oh, goodness. Oof. Excuse me. Okay. Okay. Just slap that. Okay. Never. That's an unstable feature. Good. Try reserve error. That's a public. Can I make my own? Kind. It's a private though. Can you? Is there a constructor? There is. Okay. Oh, unstable. Buh. Yeah. That's interesting. Oh god. So we need this type. Try reserve error. And I located it in collections mod. Really? I don't think, you know, you can't have a collection hash map callback. Doesn't work. Can you have a B tree map? B tree map. I don't know. I don't know the specifics. Ouch. Nah. Okay. So mod collections. So this is, let's go like error type situation. Oh, and then we got that fella. Really? Layout. I don't. Is that allowed? I think it is. No way. Okay, and then are we here? No. So okay. Is that right there? What happened? Yes, it is. Clone. Molly. Clone. Okay. Okay, so we got that try reserve error. Why does it do like that? Let's find this guy. Get to the bottom. Handle error, try reserve error. Okay, so that's yes. Okay, there. This is where it's getting the variant. I guess I can just copy that. And then now that's like that. Okay. So what next? Capacity overflow. One central function. It's like right at the top. Okay. And Okay, we don't have that feature. And we also don't have this. Okay. Is never for real? Or is it unstable? I guess we'll find out. Alec. Wait, it's public. Wait a second. Can I just yoink that? Hold up. Wait a minute. Rust library Alec. Stable. Global Alec. Okay, what if I don't do this? Does it give me a hint? Yay! Yay! I don't have to deal with it. Yay! Okay. We're done on that code path. Okay, so now we have to do this type situation. Is that an enum? It is an enum. Okay, so I don't think we have that into implementation. Here? Yes, okay, into right here. Unstable. Error. Yeet. Okay, so then now that code works. Okay, so this is not real. Comp. Oops. I'll just remove this for now. Add it back when we need it. Whew, okay. How low can you go? How deep does it go? Ugh. Oh. Oh. I did not realize that it was calling that function. Shouldn't it? LM layout size. Shouldn't it not be doing that? There's this const. Why is that an argument? Shouldn't it be generic? Oh, right. Because they removed that. Well, that's weird. Okay, I did not mean to select that letter. That was very annoying. So this isn't the full story. Um, layout does work for this. I guess I splat this into the function. This is kind of goofy, but looks like it's intended to be used. So we need size and align. Okay, semicolon. Use size. Wow. Oh. You good? All right. We good. Okay, so now this one, we do lm layout dot align. Whoa. Whoa. Okay. Layout array. What the hell? So what are we looking through? Grow amortized. So we're on here. Grow one. Okay. Mm-hmm. 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 Okay. Chuck it right at the bottom. Whoa. Repeat. Private? Ooh. Use of unstable library feature. So layout array is not correct. Anyways. New layout. I'm not really sure when I need to start paying attention. with the like custom implementation. I feel like the array layout might actually be fine because like all that matters is the size. Oh. No. 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 No, I can do better because of what I described earlier with the padding not being necessary. As long as I initialize the allocation with the minimum size equal to the alignment, then it will always be aligned. Mute. Interesting. I guess that makes sense. Stateful allocator. Oh. Current memory. I think it's there. Finish grow current memory. That sounds like moving the stiff. I do need this glob. Okay, where are we at? Layout array. So we're inside of this function. Grow, 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 grow. Finish grow current memory. I need to see both of these. Oh. I see. Bitter? Who has current memory? Uh, I feel like this is doing some sort of optimization thing where, like, if the alligator goes like, "Oh yeah, you can just extend your memory. You're all good, man." Then it'll go like, "Oh great, I feel good," and then it'll just keep using it. But otherwise, it has to move it from the old one to the new one. Right? What this? Ugh. Alright, I can do this, buddy. Self is raw vec inner. The old inner. Is it above or below? It's above. We're here. Current memory. So this is 0. Unchecked mul. No way. Really? It just likes that? Lucky. Cool. Let's look at that function. Oh. Okay, easy clap, I guess. Unsafe. Who is this? This has got to be the inner. It's right above. Okay, so we don't do like that. No. And we don't do like that. Let's go. Chilling. Okay, so we just need that gosh darn finish grow function, which I am not currently understanding. Alright, I'm going to paste it in and then understand it. It's right above handle error. So like this. Sure. We don't do like this. Damn. So I'm not actually sure where it's doing the stuff. Oh, it's right here. Array. Cool. You good? All right. Well, it just pastes straight in. Not quite. Oh, okay. So it's just seeing if we currently have an allocation. Okay. So if we currently have an allocation, then grow that sucker. Attempts to extend the memory block. Blah. Okay. The allocator may extend the allocation reference by pitter to fit the new layout. So actually, we can't do that with the... Oh, we kind of can, actually. Copy non-overlapping. You know, we actually kind of could do that. Because then we could leave the first field alone and avoid a copy. A little bit crazy, but... So this is the old trait allocator. Allocate, deallocate. Is there reallocate? Oh, yeah, there we go. I see. So this is the default implementation. Contents of the memory block are unaltered. Really? Interesting. Hmm. Huh. Finish grow. So I think this function is now incomplete because I have work to do. Do we care? Oh, that's important. So in a vec, it's chilling if it grows. There's no additional work to do after you grow the allocation. But in my callback thingy, I have to move the fields up because the capacity has been grown, and it's like multiple simultaneous vecs in one contiguous region of memory. So there's work to do in this finish grow function. So where is it called? It's called right here. Okay. So if the allocation fails, sucks to be you. We want to error. So I think this is a question mark semicolon let region equals to like this, and then an OK region type situation. Oh no, type must be known. Gabba 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 wagga 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 wagga. Yeah. Into. Because it's gotta move the memory. Move uh-oh. What is compile time? So we can compile time the if statement. They have to be sorted. Compile time sort? Really? 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 That freaking sucks. Stop. Aye. That is so annoying. Okay. Oh, it's freaking the other way around. That big sucks. Alright, I'm just gonna if let, or I guess this is a let else situation. I think this'll be chill. Yeah, it's chill. Okay. Oof. Ah! Ah! Oh! Ah! This is insane. You know what? Just I think I'm just gonna allocate a new region and then copy all fields, because doing a compile time sort descending of compile time constants, that sounds like a major pain in the ass. Well, someone has a crate for it. That would work. This would work. Why isn't this generic? Oh, it's recursive, isn't it? Oh, that's nice. Huh? Last week. Ooh. Maybe it's not so bad then. I can write that down. Why did that happen? Yeah, that's actually not so bad. Ah. Ha ha ha. Oh, gosh. Well, grow one mostly pasted. Um, this ought to be easy. Let's go see how to do that. Hey, okay. I'm guessing those are like the old Rust compiler. So that is. Where is that? As better. Alright, so that's underneath the top function, so it's like, ooh, boom. So it's like here. I don't think these are real. I think it's gonna try to kill me here. That's okay. Buh. Oh, this, I pasted it in the wrong one. Right here. Buh. Wait, what? I pasted it in the double wrong one. Buh. Alright. Where'd it go? Petter. Inner petter. The. You must be careful. Oh, Schnapple. Rawr. T. That's not true. Okay, let me just rethink about what I'm doing here. Okay, so I'm copying this type situation. Oh, jeez. Vec row 1. Push. Okay, so I'm doing push. Okay, so it is wrong. Okay. So I need to do these steps for each field. Why is this in unsafe? Huh? Well, where's my implementation? So it's wrong. Yeah, that's wrong. Can you do cast? Yeah, this is not real. This is self. Let's see cast. Okay. I need bytes. Right? So I need frickin' straight up offset. And then that is capacity. Oh. Type situation, right? True. Cast, offset, add. I think that's correct. Is there a freaking like type? So that saying like this is the same type as that. I guess that'd be troublesome. Good. So I'm gonna move this down. I don't know why that's unsafe. Let's do macro rules. Oh god. And then say, oh, it was there anyways. Okay. Ugh. You there. What happened? Oh goodness, what the heck? Sucka, that's unsafe. That's so unsafe. So as a field 1. So we got all we really need to know is the offset and the type. Can I just say U size? Do like this. So so it's gonna be like right field, and they'll be like, ooh, we're doing field 1. Ooh, offset, and then the type is U8, if I am not mistaken. Are you trolling? Ident. Okay, EXPR. Wait. Okay, so cast TY. That's why I did that. Oh no. Oh no. Expected I size, found U size. Is this chilling? What if I add? Cast This is probably like the worst possible thing you can do, but add this cast at length. Oh. Okay, so this is gonna be field ident. Uh, value dot field. Two, three, four. Why was that the first thing I see? Because I'm doing stuff that's spooky from raw parts. I'm doing diabolical code. Like, that's what's going on. Data. Oh, it's a constant pointer. What are we doing like this? Self.len. Yes, okay. Self as field one. Okay. Putter. But we don't have that function. Putter. Oh. Putter here. And then is there? Yes. Okay. Boom. Who did this? What is this? Oh goodness. Okay, I can go like this. Self is vec. Yeah. Okay. So it's over here. Wait. Deref. No. We don't have deref here. You can't do like this. So these have to be private functions. Oh my god. Okay, is that safe? This is not safe. Okay. So we're doing boom. Yep. Boom. All right. From raw parts. What the hell is going on? Okay, so we have data. We're like trying to make a vec thing. It's like a vec, and it's like allocating. Oh, it's cool. So we have this transpose layout in memory. Wow, very cool. Ooh, it's transposed. Ooh. So what's happening is we're trying to get a slice of field 1. So we're trying to get this slice. We're trying to go like, oh, there's the data. You asked for that data. There it is. So there's this unsafe function where if you misuse the function, it will have undefined behavior. So we have to say safety, I know what I'm doing. I'm going to need safety comments for every single unsafe block. But what's going on here? So that is not... Yeah, okay. So it's the pointer to the inner buffer something great. This is like the pointer to our allocation. Wow, that's cool. That's the pointer to our allocation. So then we're casting it to a byte pointer. So now it's a pointer to a single byte. We're adding the offset of the field times the capacity. That goes like to here. So that's like, it's a pointer to right there. And then I missed a step. We have to cast again to the actual field, but it wasn't necessary in this case. Undefined behavior in Rust, only in unsafe blocks. You can only access the like under the hood, faster, better, stronger stuff when you really need to by using unsafe. It's like, it's I solemnly swear I know what I'm doing to the compiler. And the compiler's like, all right, you got to uphold all my invariants. You go right ahead and knock yourself out. Okay, so field 1 slice. Wow, that's a slice. Wow. Is this const? Wow. Let's go. Okay. This is const as well, isn't it? Dude, this is const. Easy clap. Easy. So easy. Game is so easy. Okay. Yeah, I'll make it into a macro. Oh. Wait, is that allowed? Can I do that? I guess not. Yeah. Okay. So now we have mutt. Oh, good. Mutt. So this is gonna, when I press S, it's gonna say, actually the type is not the same. You said it's a mutable slice, but this is just a normal slice. So we need mutt. And then this is as mutt pointer. Oh, mutt. It's mutt. And that should fix it. It didn't. Oh, it's because this needs to be mutt as well. So we must have a mutable reference. We must have mutable access to this object. Then we can grab the mutable pointer out of it and then do everything wrong. Okay, so now I'm going to make the macro. Don't look. Macros, holy smokes, they're macros. Macro. Make field access. I guess I'll call it that or something. Okay, so, functions. So then we're defining this block. Wow. What is that? Okay, that's the thingy. Yeah, another tab. Okay, so what are the arguments to this macro? So we have the name of the functions. I guess okay, so here's the order I'm going to do. So first argument is going to be field name. Field. And then it's going to be, what is that? It's an ident. And then it's going to be the field type. Then it's going to be the immutable slice ident. So oh, thank you, brain. Okay, so then it's a type. No, it's an ident. We'll call it immutable, and then mutable is ident as well. Okay, so there's 4 arguments. Let's fire up that macro. Field access. You know what? This is a stupid name. We'll do impl. Sent that 1 minute ago. Sorry, I was a little bit focused, locked in. Okay, so this is the immutable one. Wow. And then this is the tie. Watch this. Boom, boom, but not that one. And then this is the mutable one. Boom. And then the tie. TY. Boom, boom, boom. And then this is the field over here. Boom, boom, boom. And the dot to do it. So now we need the repeated part of the macro. A little bit insane. So $, believe it or not, and then star. Now we have a repeated element. So now we go like, oh, I have these fields, man. I want to put my fields on, man. Actually, I think I do like this, comma. Okay, so I am trying to go like field tie imut mut. Okay, so what's the field? The field name is field 1, not 12. The type is U8. I want to call the function to access the slice field 1 slice. I want to call the function to access immutable slice field 1 slice mut. And it works, definitely, for sure it works. What's going on? Const. I can do const here as well. Expected simple binding. Is it trolling me because of this? Huh? Did I do it wrong? Why is it trolling me? Is that allowed? Oh! Okay, so now it says... I don't get it. Okay, so we can just do like this. Go! 2, 3, 4, and then put the types in. Option. This one is a I16. This one is a U32. And there's no comma there. Why is it trolling me? Nested binding. What the hell is that? Huh? This is a for fun library. Yes. Technical for a friend. Yes. So my friend was making something, and I was like, oh, the Ziggy thing would be great. But the Ziggy thing doesn't exist in Rust. Okay, why is this so unorganized? Let's put this like this. Tabs. Okay. Is it going as easy as you thought it would be so far? I don't really think I thought it'd be easy. It's very wacky. Oh, I know what's happened. This is supposed to be repeated, but it ain't. Boom. 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 Okay. Okay, so we're repeating this entire block with the $, open parentheses, close parentheses, star. So it's going like... Okay, and we're defining all these functions. Wow. And then this is also that. Wow. And then this function signature looks like that. Wow. This function signature looks like that. Boom! One macro instead of repeating this 4 times. Okay. Macro. Okay. Library does not quite compile. Oh. Rate this setup. Just get my stream on the TV. Chicken and broccoli? You cannot get healthier than that. And rice? Gaines meal. It's fish. Original human meal. Fish. I'm a human. I like fish. Tilapia. I don't know what that is. Okay, so this is problematic. Raw. I think I should do like this. Huh? 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 Oh, I closed it. Oh. Oh, I'm stupid. Wait. Okay, what happens? Putter. Really? That's allowed? You can do that? Cast. Oh. Yeah, so I think I'm gonna say it's one of these instead of one of those. Okay, where's thingies? Okay, so yeah, we're gonna do like this. And then consider changing this to be mutable. Oh, did I do that? I did. I forgot. Okay. So it's a ooh ooh ah ah, and then we don't need this step anymore because everything already does that. Yeah. Okay. Well, there's one little problem. Okay, layout array. This is gonna segfault the instant I try to run it. Yeah. Okay. Let's see. Repeat. Is this also unstable? Pad to align. Repeat packed. Yep. Checked mul. Size. Internal helper constructor to skip revalidating. Layout. What about the old alloc thingy? There's the allocator API. Rust allocator API. Three months ago. Okay, what am I looking for? Something. Repeat. Why? Where? Alloc layout. So that splice. Does this contain the thingy? Vac. Oh, Schnapple. Where's the old? Why is Ravec outside? Oh, I see. They have all this stuff. Oh. Oh, that's not the same. So I like did something similar here. Pub crate struct. I don't think I'm gonna find it. We'll see. Repeat. Slice repeat. Wait, Vec. Bah. Huh? Don't it? Extend into iterator. Isn't there references to the values? T. What? This is Oh, I see. Okay. Unsized, dynamically sized type. Okay. But isn't that still a reference to it? Ugh. Wait. It's copying itself? Jesus. Ugh. Unsafe. It's a copy non overlapping. There's a memory invariant that has to be upheld here. That's why it's unsafe. You have to guarantee that your two pointers don't overlap, your two memory regions. And you just gotta know. Yeah, that's like a runtime thing. Like you'd have a runtime check, right? Like checks and like looks at the numbers. Oh, your things are overlapping, but like if you already know they're not, then you can use unsafe and skip the check. Well, it doesn't have this function. I'm just gonna blast it in there and we'll call it a day. Alrighty. So this is layout. Let's go. And then this is layout. And this is layout. And it hates me. Private field. Fair. Call it like that. Come on, bruh. Oh my god, bruh. We can't get a leader on here. Is that real? So this is a private function. How do you do this? Something unchecked type business. Type situation. Okay, unsafe. GG. And then layout error. Use core alloc layout error. Come on, bro. Expected result. That's so true. Okay. You good? What do you want? Layout error is returned when some other thing. Expected value found struct. Huh? Is this trolling me? Are you trolling? Constructor is not visible due to private fields. Okay, so you can't construct it like this. Non-exhaustive. Yes. Okay, so they've done black magic to make it so you can't construct it. But we actually do not care. We do not care. So what we can do is say struct, and it's done. No problem. Okay. So then this one's like that. Okay. My God. Okay. So now I can watch the program segfault. I get the privilege to watch it segfault. Let's go. Okay. So I need to write a test. Let's go. Okay, so this is like bare minimum implementation, 400 lines of code. Okay. So now I test it. Pubconst func, you know, it's not public. Don't be doing it like that. Nope. Okay. How do we do? How do you do? Do we do? All right. New. No function new. Oh, it's that one. Okay. Fair. Okay, so we want this type situation. Huh? Yeah. That's not real. That's not real. This is real. What? Field 3. Fair. Field 2. None. Field 3. Field 4. Multiple methods are never used, actually. Okay. Hell yeah. Look at that. It's already giving me an error. We love Rust. Yes. Okay. Let's see that segfault. Time to segfault. Give her all she's got. Cargo test release. Segfault, 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 segfault. Failed. Ah, I didn't implement it. Right. I didn't implement the library. I forgot. This is very confusing. I don't feel qualified. But that's why I'm here. I'm trying to learn about it. Oh. How long have I been streaming for? Wow, 3 hours making the bare minimum implementation. I think I need that crate. Give me that crate. Give me that crate. Try not to use a crate challenge. I mean, do you want to implement compile time sort? I don't think so. There's a crate for that. Oh. Oh, cunt. Mm-hmm. Yeah, let's keep going. Compile time sort. I need it. I need it. Okay, rar. So, all the way up here. We, um, sorted field offsets used to move into new allocation with copy non overlapping. Okay. Why don't I make it pop it, pop it, pop, 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 pop? Can you do that? I would need a count macro and then -1. I could probably do it. I'm just gonna not do it. All right. Should I skip rev? Okay. Const. Sorted field offsets. Const. Ah, crap. Okay. Frickin', it's a stupid array. I don't care. I don't care. I do not. We do not care. We do not care. We do not care. Use size 4. We do not care. Okay. So then, oh, I have to add it. Okay. Cargo add. I'm gonna need a macro. Whatever. Okay, just go for it. Oh, right. We need to specify callback. So this is like the test implementation. Ooh, okay. It's right here. Okay, sorted compile time sort. Sort. And then like that. Type stuff. Okay. 4. Okay. Let field offsets equals to array. Yes. So I'm just gonna do it. All right. Good. Offset of test. Oh goodness. Don't do that. Test. Field 1. 2, 3, 4. Really? Would oh. Okay. Smash it right there. Impl on test. Yeah, why not? Why not? Why not? Impl test. Sorted field offsets. Ooh. And then, yep, there it is. Pub. Oh, okay. It's done. It's sorted. We got it. There it is. Got 'em. Done. Okay. So now, in the function, right here, we do the for offset. Uh-oh. No, it'll work. Because it's capacity. In dot into iter dot skip dot rev one rev. Okay. So surely this all compiles out, but just making it proof of concept. Okay. Tabs. Oh, okay, so that's an offset. So we're in order. Is it ascending or descending? Huh? What does it say? I'm guessing it's ascending. Is sorted. Good. Okay. Okay. Yeah. Yeah. Ascending. That was my assumption. Okay. So I skip the lowest field because it's already in the right spot for grow. Oh goodness. We have nothing to do here. Hold up. Wait, what are you doing? Didn't you convert to tabs? Huh? Why did it not convert to tabs? Huh? Here's a selection. Tabs. Oh. Okay. So it's trolling. Okay. Cool. Okay. Okay. We good? Not quite. Whatever. I'll just remove the thing. Yeah. Yeah. Just remove that line and we're good. And put that one back. Huh? Okay, what does it happen? We're good. Or does it doesn't matter. Okay. So we have this loop. It's going 3, 2, 1. Well, no, it's the values. So copy. We're doing copy non-overlap. It should be easy. So easy. Unsafe. Copy non-overlapping. Why is there 2 of them? Help. Qualify. Intrinsics. Pointer. Huh? Is that how you... Who did this? Lenovo ThinkPads. Never used one. Actually, I think I've used one in like 2003. So, a little bit out of date. X13 installed Debian. Yeah, maybe my opinion isn't the most valid. Not the most up to date. So, what? Copy no. Okay, so this function exists somewhere. Drink water. Definition, let's see. Copy non-overlap. Okay, pointer, that's the one they use. Okay. Unresolved. Okay. Okay. Yeah. Self. Okay. Yes. 3 arguments. Yes. Source, destination, count. P. Not gonna work. I guess I can use this. Okay, it's gonna be generated code. So I don't actually need compile time. Well, it is gonna be compiled. I don't need to like have this sort crate. I'm just gonna go like, sort it, generate it, and then it's done because it's a proc macro. Okay, I'm gonna undo. We're gonna go back way back in time. Okay. The macro. I need a macro. Macro. Is there any macros in here? There's gotta be a macro. There's no macros? Oh my god. Okay. Man, it's like this. Okay. I need to know the old capacity. I think you would love a ThinkPad. I think I would love a ThinkPad. I have an old Asus laptop with a 1070 NVIDIA back from the before Linux times. That thing will never have open source drivers. This driver version is the last version that supports the graphics card. Thanks, NVIDIA. The something. So it's gonna be something like that. Field tie. Let's try that. So type situation, unsafe. Okay, it's gonna be out here. Don't use right field copy. Let's do copy. So it's gonna be like go live in the woods. How do you get internet though? Is it mutt? Const mutt, super cool. I love function. There's just making everything the correctly modeled type is such an amazing programming strategy. Like once you do that, basically the code writes itself. Okay, source. So so what do we got? So we got like source. Okay, so now we have offset. It was a constant though. Whatever. It's not that big a macro. I'm just gonna smash it through. Wait, do we? I don't have a macro here because I didn't need it, but now I do. Okay, cool. There's something. Okay, so we're calling this function. So we need source and destination. Source equals to self dot as butter dot add old capacity times offset dot cast tie type situation, and then we do source dis len. Is it self dot len? Do we have len? Is it gonna know len? It doesn't know len. Okay, the grow function doesn't know enough. And also, this code goes somewhere else. Pizza time, 15 minutes. Ugh, okay, so I'm thinking it goes like this. And we can do this type situation right here. And then this type situation right here. And then the old type situation. Where did it go? What the... Huh? There it is. I knew where this was. I didn't need to do that. Okay, so then this thing, we can map error directly on this guy. Be like, error, and then that's it. And then this business belongs right here. Ooh. You good? Okay. Yeah, no, we're not gonna do this. Because this path does need to move the thingies. This path is chilling. The vec is length 0. Wait, equals current memory. Like, okay, sum. As in, it was previously none. No, there was no allocation. Current memory, boom, allocation. So, if there is an allocation, it does this. If there's no allocation, okay, it's a new allocation, and you don't need to move anything because there's nothing there. Yeah. Okay. Okay, so we got source. We got dist. Self cap. That's cap. And then DST. And that's how we do. What is okay, we actually don't know anything. It is completely dumb. Well, guess we'll do new capacity and len. And we have a pointer. Wait. Pure. Okay, cool. We got it. It's right there. It already got it. Okay. Is that allowed? Okay, so we do like, copy field, and it's like field 1. Type is hoo-ha. And then it kills me instantly. Okay. So it's gonna look exactly like that other macro right here. Cool. So I'm gonna smash that straight through. Copy. And then offset. We can also steal that. Like this. Boom. Bye. And then I guess we need the macro. Use core. Gah. LMN. mlen. So we need all this garbage. Old, new, len. And there's just usize. Okay, and then as PTR. Okay, so then what about this? Field 1 is private. Shut the up. Shut the up. How does okay? That's. What if I just say this call function unsafe something so I can keep it private. Oh, I almost did field 1. And it's like, oh, that's right. I need to know the order. Wait, is that not possible? I need to know the layout. I think it was 4, 2, 3, right? 4, 2, 3, 1. So field 4 is chilling. We need 2, 3, 1. Like that. This is very specific. So this is like move this is gonna be a goddamn unsafe function situation. This guy doesn't exist. Is this a circular dependent? This is a circular dependency. I'm just gonna like put it in a function because like okay, this is not real. Prototype. I don't think it cares actually. Unsafe function, move fields. All right, it's chilling. The fields are moved in offset descending order, and the field at offset 0 is skipped. XD. Okay. Huh? Oh, wow. Okay. I could just put her at, and we're chilling, so. Yeah. XD. Okay. So then we don't need this guy. Backspace all the way. Great. And then now we use Stupid function. Stupid. Okay. So we have both. We have, okay. Let's go. Okay. So we're calling this with like 18 arguments now. So let's go. So old cap is self.cap. And then new cap is cap. And then len is self.len. Do we know the len? We do know the len. It's len. Did we add the len anywhere? No. Okay. Well, that was fortunate. There it is. That's all the information we need. Okay. And then now we have to put that here. Move fields. Putter as putter. Comma. Well. Well. Now we remove this. Cargo remove. Oh my god. So now this is part 2. Fix this. Yeah, move fields. Let's go. This is just the implementation initially. Oh my god. Okay, so we pushed a test. Now we're trying to read it. Well, let's see the legendary seg fault in Rust. Time to see it. All right, test seg fault. Where's the seg fault? It works. What? I didn't write bugs? Okay, there's there's got to be a test suite, right? For standard library vec, right? Let's browse that. Where is this? Okay, so it's user lib. Can I just have this? Help. Tell me that. Copy path. Thank you. Okay, so we're going to do open up this guy. Ooh. Sure. Alec. Yay. What am I doing? Cow. Tests. That's not a lot of tests. But is it enough? I can't believe that worked. What the hell? Friggin' it works? There's no seg fault, alignment error, ding dong, bing bong. Damn. I need water. There's 2 tests. Empty test. So this is testing the proc macro, which doesn't exist yet because I haven't made a like basic implementation either. I'm planning to just like scope out this like test object and just like have this like manual impl. So I might need the compile time short crate after all. If I don't have reflection in the proc macro. Reflection of the struct field offsets. I could have 2 proc macros and they layer on top of each other. That. It's kind of worth it to drop a dependency. Wow. All right, let's try adding like a bunch. So what is this? Is size 12, align 4. So it maybe made 8 elements. What's the, how do you do it again? So it's got this function called not be stupid, vector dumb. So if the size is 1, it's 8. So it did 4. So it said 4 is not less than 4, so it's 4. Okay. Interesting caveat. The minimum length is equal to the alignment. Hmm. Hmm. How's your pizza? Pretty good. I'd say it's about $25 good, but the pizza was $40, so. The ratio is a little bit off. And I would call it expensive. Okay, so Roblox BHAT money. It's Canadian dollars. Monopoly money. Okay. Let's try pushing a bunch of these. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's more, isn't it? And see what happens when I do that. So does it segfault here? Oh, I'm stupid. Okay. Does the allocator do the copy? Yes, it does. Okay, so let's test failure. Is this UB? I don't know. Probably. I have no idea. Vealed one slice. Okay, what if I just like bust out the whole thing? That's what happens. Hmm. 1, 2, 3, 4. No capture. So I made some kind of misunderstanding or assumption somewhere in how the allocators or unsafe code works. Isn't this 0? 0 times. Let's copy field. So old capacity times offset, new capacity times offset, 0, 0, len. That's an overlapping copy if I ever seen one. Wait. This is wrong. Copy not overlapping? No, it's doubling. The capacity doubles. I cannot visualize that. Is it possible? No. Oh, wait. Oh. Oh, it's not field 4. It's field 1. What? What? Oh. How is that possible? Okay, let me double check the order here. So 4 is 0. That's the smallest number. These have to be order. Here's the offset right here. These have to be in order, increasing. So 0, 2 is 4, 3 is 6, 1 is 8. So those are in increasing order. Am I stupid? Yes. Okay, yes. So these are in increasing order. I needed to do decreasing order. So this was the problem. Bop, bop. Okay, so it was like going on the data instead of like dooch, dooch, dooch. It was doing something else. Hell. Yeah, so this should fix it. New pizza, next pizza slice is ready. Just in time. Hello, Doko Gaming. I made it work. It works. It's absolutely atrocious that it relies on the field order. I actually didn't know that Vex can grow in place. That's pretty cool. Wait, I'm stupid. Loop it, man. It's a program. Okay, so nice. Big. What are you working on? It is a transposed growable array of structs called a struct of arrays. I have not seen anyone do this in Rust. Okay, so I have my proof of concept. What are we at? 390 lines of code? Really? That's not bad. It is very minimal. That was tough. All right, I'm gonna show off. So most of my time went to dealing with the unstable features that the standard library publicly depends on, well, privately depends on for its public interface to function. So there's like internal functions and types and stuff that it doesn't expose externally, but it relies on internally to function. And that was the main time sink, was figuring all those out and like pasting what I need, using what I can externally. Pretty cool. This library is totally is the type of thing that needs to be like no STD and like allocator API. Actually, right. Right. Okay. Right. Right. So default, it'll just use the global allocator and not have allocator API dependency. But then you can say, oh, allocator API. And then you can use your own allocator. Or you can say, oh, no STD. And I guess that's the same as you need to use your own allocator. This is looking like a time sink, which I expected. Oh, but I certainly learned a little bit today. Probably the most interesting part was moving these fields that I did just now, where like it has to do it in the correct order and omit one of the fields. Although, like, both of those are actually required for it to function. Wait. Wait. I don't need to use the compiler offsets. I can make my own offsets. I can just partial sum the field sizes. Huh. Huh. Yeah, that'd be pretty easy to do. Is there any benefit to using the compiler offsets? I don't think there is. I think there's only downsides. I'm gonna write that down. No downsides is what I like to hear. Sick. Oh my god. Look at that time jump. It took the whole stream. So I published this right before I started the stream so that no one would snipe my crate name. So I'm squatting on the crate name right now without it implemented. Which is another way to make me do it. Why does your crate not work? Man. I'm expended. Four hours. I was lucky that I hit the field order, the field that broke. What time is it? 8. How do you get this? Let's see. Goba, del Goloba memory allocator. Huh? They just redo the old Rust global allocator instead of just using the Rust. What if I do like you go away and I do like use global? STD alloc global. It's real. Okay, that's easy. STD alloc global. Let's see, how do you make a no STD? How do you do it? Create level. Let's see what happens. It should be fine. So I go like this. Core. Alloc isn't part of core. Okay, what about allocator API? Alloc. Ha! Okay. That was easy. No STD. Let's go. Okay, so then I understand. Okay, so here's what we do. We go like feature no STD default is nothing. Type situation. And then we go like CFG feature no STD for real, and then we go like CFG not feature no STD. Hey, and then and then we go like, hey, STD, and it works, except it doesn't. Wait. Oh. 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 Ah. You can't. Wait. How do you do this? Wait a second. Ah. No STD. How do you do that? Okay, who Ugh. Tiny vec. Let's go with this. Because this is like I'm re-implementing vec in a different way. This is the exact same thing. So no STD, no way. So how do you do this? Source, lib. Oh, that's how you do it. Oh my god. Oh my god. Okay. STD. Yeah, I mean that's better. That's better. That's better. These guys, they know what they're doing. Huh? Oh. Right. It's not stable. What? Okay, let's keep searching here. Vector. That one. SDD. Damn. SDD.
Oh. Uh. What I'm looking for is how does it allocate? Self with capacity. Vec. Oh. Well, that's easy. Okay, so they just shut this off, right? Because otherwise it would need a different type. So in their like std bing bongs here. Alec. Yeah, okay. Wait. Why is that different? Let me look at the thingy. You. Features. Alex stood Alec. Huh? Okay. So this doesn't implement the allocator API. Okay. So it's not a good example. Well, it's a great example. It just doesn't have what I want to do. This song. Gang's back. Sure. I'll be right back. Losing the pointer will leak memory. What is track color? Okay. Really? This function is expected to be deprecated in favor of grow and shrink. Huh. Should I consider sleeping? You have no obligations with respect to the stream. I'm about done here. I might get into something else, but probably I'll just keep working on this tomorrow. What I can't figure out right now is how do you use the standard allocator without using vec? And I think you maybe can't. Let's look for another crate. So what's another thing? So okay, buffalo. Buffalo. Oh my god. Buffalo. So how did they do it? Wait, ND array? What the hell? What's up with this? That is not what I was looking for. Rust. What's it called? Is it not Buffalo? Bump allocator. Bumpalo. I'm stupid. Bumpalo. Oh my god. Okay. Why didn't it have a readme? Because it was the wrong one. Okay. Incredible. This is programmer art. Okay. Yeah. So it's gonna do something. So let's look at the features. Create features. It's what is Bumpalo? Bumpalo is a bump allocator. So this is what I used for my hashster library. Where's my stuff? Just go like this. Hashster. So I thought this was a good idea, and like, it's interesting, but like it can be replaced with nothing. You could just not have this library instead. And I used Bumpalo in this library. Do you know what a bump allocator is? It's very simple. So what a bump allocator is is it's basically trying to be the simplest possible allocator. You reserve, yeah, okay, well, I'll explain for anyone else watching. You reserve some amount of memory from the operating system, and then when the code calls the bump allocator, it just bumps the pointer up to how much bytes you allocated. I was joking? What do you mean? It's simple. It's the simplest possible allocator. And so if you request something else, let's say I want 5 bytes, boom, 5 bytes. Those are my bytes. I want to allocate 23 bytes, boom, 23 bytes. Those are my bytes. All it does is just bump up the pointer. It's the simplest possible allocator. I don't know what's a bump allocator. Okay, well, I didn't have that context. I didn't know. I had no way to know whether you were joking or not. So you can imagine that if you're implementing an allocator, you could be smarter about it, where like if someone drops memory, then now it's free for other things to use, and suddenly the bump allocator doesn't work anymore because the bump allocator only goes this way, right? So that's what it is. It's an allocator that's extremely fast, but has very is very simple and dumb. And if you have complex needs for allocation, it's not going to work well. But with this, the idea is you have a string internment cache. So your program has a fixed set of strings that it can come across, and it's no more than a fixed number, like 200 or 2 billion, whatever. It's fixed. The cache uses a bump allocator because it never frees the memory. So you don't have to worry about, oh, this is freed now, we can reuse this. It doesn't happen. The memory is freed all at once. You drop the cache altogether. So I use Bumpalo internally, and it just grows the cache, and you're like inserting your strings into the bump allocated memory. And then if you like, you can drop the string cache and it drops all the memory at once. And I don't need this complex, like, oh, string number 5 was actually deallocated, we can reuse that memory now. No. So it was the right tool for the job. And the point of this library is that the string has a pre-computed hash. So if you're trying to like test strings against a hash table over and over and over and over again, you're going to be recomputing the hash, especially with like long strings. You're going to need to go through the whole string, calculate the hash, and then you can access the hash map. But with this, the hash is pre-calculated. So it just goes, oh, that's the hash. And it finds the hash map entry or whatever using the pre-calculated hash. But it turns out you can just design your code better so that it only ever hashes the strings once. Instead of rehashing things, you just do a better job not doing that, and then you don't need this at all. So I spent a month writing this library. It was very fun. I learned a lot, and then I didn't need it. But I don't regret it because I'm here for the journey. And like it's so cool. Like you're like, oh, this is a string. It's calculated at compile time. The hash is calculated at compile time. That's so cool. And then this is runtime calculated. So this is like a boxed. I guess you don't know Rust. This is like a unique pointer. to a string slice, which is another Rust term. Something is going on here that's rusty. And then this is the cache, and it has two parts because of borrow checking rules. So it has the bump allocator that hosts the data, and it has the cache, which knows where the data is in the allocator. So that it knows like if you're looking for this string with this hash, well, the memory is over here. And it keeps track of which strings are in the bump allocator. The bump allocator has no idea what it contains. It just knows, oh, you added another 5 to the pointer. Good job. So then you have your cache. That's cool. So remember I mentioned string internment. So this is interning the string into the cache with this backing storage. And then you can do other cool things. And then it has like borrow checker guarantees and stuff. It's really cool. And you can make sure that the pointers are equal because you already interned the string. So it'll only be one copy of the string. Because like that's the point of it, is to have a fixed set of strings. So if you intern the same string again, it should be the same pointer. It should return you the same pointer to some string inside the cache. So cool. I kind of dabbled with custom allocation and unsafe code. This was only 4 months ago. So yeah, there's I have precedent. What was the Bumpalo? That's I wanted to see how it does its actual allocation, because it has the allocator API. So okay, SDD features. Oh, huh? Default no SDD? Dependencies, hard dependency, option equals. Oh, it's not a hard dependency. Huh? 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 What? Do I have this here? No. Hello. Nope. Get over here. Okay. That's wrong. Where did it go? Huh? Oh, I opened something stupid. Hello. Okay. So it's Said. Allocator underscore API. What? Alec. That sounds good. How about that as a starting point? Core Alec layout. Huh, they have their own repeat. They had to do the same thing I did. Way back. Size align, I guess. Oh dear, this has got to be the main. Okay, what? Wait, why do they have their own allocate? How many dependencies is here? Allocator API. Serde. What? Why? So they have their own freaking alloc? Oh my god. Why? Hmm. This is a lot of code. Why? Okay. Huh. Huh. Well, there it is. That's what I was looking for. Ooh. Ooh. You love to see it. Look at the oh wait, is that behind my camera? That is. Look at this. So like non-null. That's what these are all the places that non-null is used on the scroll bar. But then alloc, a singular one. Looks like there might be some tests here. No, this is just unused code. A singular alloc. New chunk. That is what I like to see. Singular dealloc. One call site. Yes. Okay. Well, allocator alloc error. What? Oh, so if I just go like, and then I go over here. So I just go like core alloc. Why? Why can't I do that? Huh? I don't get it. What did I do wrong? Rust core alloc. Yeah, allocate. I'm confused. Oh. Oh. How did you fix the problem with Zed? Is it where it like instantly crashes? It fails to start up. I'm using X Wayland. So like this. That's how. I'm just hoping it goes away next version. It's taking a while. I think they're working on like a major version. It's version. It's going right now. It's version 299. Is that 199? That's gonna become version 200.
No way.
I'm confused. How does it know? Can I just do this? Oh. Oh, how did they do it? So I think it's only because you have a single alloc call site. But the, but the, but, but the, but then how does it do this? Is this like waiting for the allocator API? This is like you just turn this feature off, turn this feature on when it goes stable. That's kind of smart. So how do you like find it? Oh, wait. Oh. Okay, so they're just doing like self methods. So this is the trait over here. I'm still confused. Is this unused? I am confused. How does it switch the backing allocators? So this is getting called from here, yeah. So what, it's just hard coded to the global allocator? And then I guess so. I guess it's just hard coded to the global allocator. Well, I didn't expect that. Okay, so it implements the allocator API for itself because it is an allocator. It's the bump allocator, but the library is only configured to use the global allocator. It's a proxy allocator ish type situation. Because like you're not going to use a bump allocator for like the Linux kernel. You would run out of memory in seconds. It would break. Seconds. Okay, readme, I guess. Oh, jeez. Where did you go? Here it is. Okay, what did you say? Fast. Limited, yes. That's it. The global allocator. So it does not implement custom allocators. Someone open an issue. It's probably old. Allocating underlying store from a non-global allocator. You now want the backing storage coming from a global allocator. Hi, planning a new release 2024. One of the features is being generic over an allocator. So they haven't done it yet. I was going here to get an example of what to do, but they haven't done it yet. Ah! Ah! 2 months ago. Allocator API got updated. Where? Bump version. Holy. Oh my god. Where should I go then to get an example of what to do? Because like it seems like there's conflicting interfaces where like I need to have this A that's like arbitrary, that's generic over the allocator trait, but then the allocator trait only exists either in unstable or the allocator API. So if I have neither of those, then what? Okay, this doesn't work. So the problem is this is unstable. I mean, this is like a proxy for the global allocator, isn't it? Alloc. Well, I could just straight up depend on this. How many dependencies does that have? Cerde. Wild. Yeah. I guess I hard depend on that. Default is no STD. So what if I do this? What happens? Okay, we're chilling. Why do I need okay. So then same dance right here. I guess I don't use that. Is there a freaking grow? Is there use core alloc grow? Help. Okay, it's alloc. Oh, this function Baba Booey is expected to be deprecated Baba Booey. That's crazy that they made such a outward facing change to the way just allocation period works. Realloc, grow or shrink. Okay, I think I understand. So I'm just gonna go full on this. So I'm gonna try to rename this to allocator API. Yeah, I think it's better as STD there. So STD is So no STD by default, I guess. But then it like indirectly is STD, but also like I don't like default values for generics. Like I think I'm gonna make an accident. I'm gonna implicitly use it when I shouldn't. I guess you literally just wrap it with one that doesn't have explicit and then you're good to go, so. Even a type alias, I think. Where'd it go? Okay. Okay, so what did I change here? So I said, ooh, no STD, lol. Why is this like a comment? So I'm using it as a hard dependency. What about okay, so this is okay. Default okay. Okay, I understand. Okay. So okay. I can do this. Okay, so it goes like version equals to this. Default features equals false. And we do like STD is allocator API to SDD. And default, yeah, really? Huh? Running 0 tests. Did I just build it? Cargo test. Running 2 tests. Wait, what? Okay, that's what I thought. Yeah. Why did it work? Oh. What? Oh, I've confused myself. Oops. I have confused myself. So the choices are either STD or STD. In order to actually be no STD, this has to be disabled. So I need like this. Allocator API 2 equals and then STD and then allocator API 2 is the default feature and then wait, is this dep? Okay, what if I do no default features? Okay, I think that's correct. And then features allocator API 2. Huh? Okay. What? Oh, that's STD. Huh. So, both of these functions. Oh, that's the standard library. Wait, what? Allocator API, excuse me. Eh. Guh. Alec, I'm stupid? Wait. Oh, I was already there. Alec. What? Yeah. This was found to be problematic. Okay. So this is what they recommend. So I'm going to do that. So, oh, we need global. Wait, what if I had a type, a public type alias that defaulted to global and the normal ones didn't? Goba. Not okay. So I could just rename this nightly. And then literally it's SDD. Type situation. And then same deal. And then nightly. And then so this doesn't work to disable that. So I discovered that this is actually wrong. This thing is better, but also worse. Oh, I broke it, didn't I? Where'd the function go? What did I do? It's supposed to... Oh. Oh, I never did that in the first place? Oh, God. Where did it go? There it is. What? Okay, is it trolling me? I think it is trolling me, but it still compiles without the troll. Huh. Okay. Oh. I'm tired. Did I even add the feature? Yes, okay. So this has the allocator trait, but it doesn't have no STD. I guess if you're right? Yeah. Because if you try to compile with no STD, without this guy, it goes. You can't do that. So I would have to do like this. So anywhere global shows up, including here, would be non-good. Okay, why is there so many underline? Oh, it's okay. So it's only like 1, 2, 3, 4, 5. I can do that. What about here? Global. 1, 2. So literally, I just add new in and like mark these as global. Yeah. Oh, so I need like STD nightly. If there's 4, there's nightly and STD. So the global allocator is STD. The core allocator is nightly. Right? I'm done. It's time to go. Time to go. Um, 2 features, STD nightly. Help. Alrighty. Alrighty. So I'm just gonna leave it there. So it was funny. I thought I did no STD, but what I actually did is I proxied STD through Alligator API too. Funny. But it shouldn't be too hard because maybe I'll make it a file. No, I can't. I can't write. This is a test, right? I need to code gen it. Yeah. Oh my god. Oh. Yes. Too much. Okay. Oh, I've turned on my camera. No. No one said anything. I turned it off for a moment to show like the sidebar on Zen. Never turned it back on. It's happened before. All right. Well, I'm gonna end the stream. I'll be back tomorrow. Probably work on this. This is very engaging. I really feel like I'm learning. Yeah. Goodbye.